In this video, we're going to take a look at what exactly it means to take the converse of a statement and how exactly we can apply that idea to the Pythagorean theorem. First thing that we need to take care of is we need to know what is a converse of a conditional statement. First off, a conditional statement is anything in the form if something, then something else. And a lot of the time you'll see people just use a letter, and this letter A just represents some declarative statement. If A, then B. That letter represents some other declarative statement. For example, that's a conditional statement. If the date is February 14th, then it is Valentine's Day. If the date is February 14th, then it is Valentine's Day. The converse of this statement is just going to take the parts that I just highlighted and flip-flop them. So a converse, a converse is simply going to take these two parts and flip them around. So my converse of that statement is just going to be if it is Valentine's Day, then the date is February 14th. So notice that that first statement went from the stuff highlighted in yellow to the stuff highlighted in orange. My converse just flips that around and goes from orange to yellow. Just to see one more example, if the year is 2013, then the President of the United States is Barack Obama. The converse of this statement is just going to be if the President of the United States is Barack Obama, then the year is 2013. One more thing that I want to discuss on this page is notice that with my first conditional statement, if the date is February 14th, then it is Valentine's Day. That is a true statement. And notice that when I took the converse of that statement, I also have a true statement, because if it is Valentine's Day, then the date is February 14th. With my second example, notice that if the year, with this conditional statement, if the year is 2013, then the President of the United States is Barack Obama. That is a true statement. However, my converse, if the President of the United States is Barack Obama, then the year is 2013, that is not necessarily true. For example, the President of the United States was Barack Obama in the year 2009, 2010, 2011, 2012. So just because he's the president does not necessarily mean that it's the year 2013. The converse of the Pythagorean theorem. So the Pythagorean theorem just says if a triangle is a right triangle, then a squared plus b squared equals c squared. The converse of that statement is simply going to say if a squared plus b squared equals c squared, then the triangle is a right triangle. Notice how I just kind of flipped those parts around, the stuff that is in red with the stuff that is in blue. And as I was just explaining to you on the last page, although not all converses of true statements are true, which was the case with our example here, with the President of the United States being Barack Obama, then the year being 2013. Although not all converses of true statements are true, the converse of the Pythagorean theorem is true, and this right here is the big idea in this video. This is what you need to be able to do. You can use this idea to determine whether a triangle is a right triangle. So what's going to happen in these problems is you're going to be given 3 different lengths of sides of a triangle, and then you are going to take those numbers, plug them into the Pythagorean theorem. If it works out, then you have a right triangle. If you end with something that is not true, then you do not have a right triangle. So let's take a look at an example of this. So let's say that I have a triangle that has a length of 3 on one side, a length of 5, and a length of 7. So I want to know, is this a right triangle? Is this 3, 5, 7? Is that right there a right angle? Do I have a right triangle or not? Well, according to this statement right here, if a squared plus b squared equals c squared, then the triangle is a right triangle. So let's test it. So we're going to plug these numbers into our Pythagorean theorem. My a value is 3, my b value is 5, and my c value is 7. So if 3 squared plus 5 squared does in fact equal 7 squared, I have a right triangle. If this does not work out, if I get a different number on the left side than what's on the right side, it is not a right triangle. When we simplify this, make sure that we use our order of operations. We're going to take care of the exponents first. We're just following PEMDAS here, and then we're going to take care of the addition. 9 plus 25 equals 34, and 34 and 49 are two different numbers, and since I ended with that false statement, I do not have a right triangle. Let's take a look at one more example. Let's say that my a value was 15, and my b value was 8, and my c value was 17. So I'm going to write down my Pythagorean theorem. I'm going to plug in my a value. I'm going to plug in my b value and my c value. One other thing to point out here real quick, make sure that the largest number, which in this case is 17, make sure that you plug that in to this part of the Pythagorean theorem. That is extremely important. And then to simplify this, the 15 squared would be 225, 8 squared is 64, and the 17 squared is 289. And if I add 225 and 64 together, I do in fact get 289. Here's an example where I ended up with something that is definitely true here. I have the same number on both sides of the equation. So a triangle that has a side length of 15 and a side length of 8 and a side length of 17 is a right triangle.